Use the two-path test to show that the following limit fails to exist. We have the limit as xy approaches the origin of y to the fourth minus 2x squared divided by y to the fourth plus 2x squared. So our two-path test has 3 steps. We need to find the domain, we need to evaluate the limit as x approaches 0, holding y fixed, and then evaluate the limit as y approaches 0, holding x fixed. So let's get started. So again, step 1 of our two-path test is find the domain. So we see that our given function here is a rational function. So we know that the denominator cannot be equal to 0. So going ahead and setting our denominator, y to the fourth plus x squared cannot be equal to 0. We see that we need to make sure that y cannot be equal to x, cannot be equal to 0. That is the only time that we're going to get a 0 in the denominator, is when both x and y are equal to 0. So therefore our domain is going to be the set of all ordered pairs xy such that xy cannot be equal to the origin. Right? If x and y are both equal to 0 at the same time, we would get a 0 in the denominator, which is what we don't want. So we've noted our domain. And so now what we want to do is go ahead and evaluate the limit as x approaches 0. And so we want to make a note here to ourselves. We're going to hold y fixed. So in other words, we're going to treat y like a constant. Don't touch it. So we have, again, the limit as xy is approaching the point 0, 0 of y to the fourth minus 2x squared, all divided by y to the fourth plus x squared. And again, our only concern here is with x approaching 0. So this becomes a single limit as y approaches 0, and we're evaluating when x is 0. So we have y to the fourth minus 2 times 0, all divided by y to the fourth plus 0. And so we simplify this to the limit as y is approaching 0 of y to the fourth divided by y to the fourth, which of course we know y to the fourth divided by y to the fourth becomes 1. So you have the limit as y is approaching 0 of 1, which is just 1. So our limit as x approaches 0 is equal to 1. So now we want to go ahead and do the same thing for y. So step 3 is to go ahead and evaluate the limit as y approaches 0. And again, we want to make a little love note here to ourselves that we are going to hold x fixed. We're only concerned with evaluating the limit as y approaches 0. So we have the limit as xy approaches the origin of, again, y to the fourth minus 2x squared, all divided by y to the fourth plus x squared. And again, we're only concerned here with evaluating the limit as y approaches 0. So we're substituting in 0 for the y. So we're left with a single variable limit as x approaches 0 of 0 minus 2x squared, all divided by 0 plus x squared, which simplifies to the limit as x approaches 0 of minus 2x squared divided by x squared. And so the x squared in the numerator and denominator cancel each other out, leaving us with the limit as x approaches 0 of negative 2, which just leaves us with the constant negative 2. So we can see here from step 2 that we had a limit of 1 when we had evaluated the limit as x was approaching 0. And then in case 2 here, we see we have a limit of negative 2 as we took the limit as y was approaching 0. So our final conclusion is therefore, since the limit for x is 1 does not equal the limit for y, which was negative 2, the limit does not exist. And so that is our final verification step for the two-path test of non-existence.